Hi, in this video, we will discuss about midpoint circle algorithm in computer graphics. It is also known as Bresenham's circle algorithm. The circle can be defined as a set of points plotted at an equal distance from the center. The equation of a circle with the center point xc, yc and the radius r is x minus xc the whole square plus y minus yc the whole square is equal to r square. If you take the center xc, yc is equal to 0, 0, that is origin, then the equation will become x square plus y square is equal to r square. Now, we use an 8-base symmetry method to make your algorithm to work efficiently. That is, we divide our circle into 8 equal octants and we calculate the points on the top right corner, and the remaining 7 octants will be calculated by using the symmetry principle. For example, if you consider a point x, y as 2, 8, the same point, when it comes to the second quadrant, it will become negative, so it will become minus 2, 8. When it comes to third quadrant, the value will become minus 2, minus 8. And when it comes to fourth quadrant, the value will become 2, minus 8. Similarly, when the point is plotted on the first quadrant, the second octant, the x and y will get interchanged. So we will get 8, 2, and when it comes this side, it will become minus 8, 2. This is minus 8, minus 2, and this will become 8, minus 2. So this is what we call it as 8-base symmetry of a circle. The equation of a circle can be rewritten as f of circle of x, y is equal to x square plus y square minus r square. Given a point x, y, the f of circle of x, y is less than 0 means the point x, y is inside the circle. If it is equal to 0, then we say the point is on the circle, and if it is greater than 0, the point is outside the circle. By keeping this equation in mind, we calculate a decision parameter. We assume that we have plotted a point xk, yk in kth iteration. Then the next point to be plotted is the x incremented by 1. So we will get xk plus 1, and the next point can be xk plus 1, yk, or xk plus 1, yk minus 1. Or in simple words, we are going to say at each iteration, x is incremented by 1, and we have to decide whether we have to keep the same y value or we have to decrement it by 1. This is the main point to be noted in your circle algorithm. So how to decide means we are going to consider the midpoint between these two endpoints, that is xk plus 1, yk and xk plus 1, yk minus 1. And we find the midpoint, and this midpoint is xk plus 1, yk minus half. And if the particular decision parameter pk plus 1 is defined as f of circle of xk plus 1, yk minus half, if this pk is less than 0, then the midpoint xk plus 1, yk is close to the actual point, so we plot xk plus 1, yk. Otherwise, we plot xk plus 1, yk minus 1. So now we will see the midpoint circle algorithm with center xc, yc and the radius r. First, we initialize the x naught, y naught, that is the initial value of x, y to 0, r. Then we initialize the decision parameter p naught as 5 minus 4 minus r. So at each position xk, starting from k0, we perform this test. That is, if pk is less than 0, then pk plus 1 is equal to pk plus 2xk plus 1 plus 1, and x is equal to x plus 1. Otherwise, pk plus 1 is equal to pk plus 2xk plus 1 plus 1 minus 2yk plus 1, and x is equal to x plus 1, y is equal to y minus 1, where 2xk plus 1 is equal to 2xk plus 2 and 2yk plus 1 is equal to 2yk minus 2, because what is xk plus 1? Xk plus 1 is equal to xk plus 1. So 2xk plus 1 is equal to 2xk plus 2. Same way, yk plus 1 is equal to yk minus 1, because we decrement the y value by 1. So 2yk plus 1 is equal to, we'll get 2yk minus 2. Now, after calculating the point x comma y, we determine the symmetry in other 7 octants and we will plot the point using the circle points one subroutine, and we repeat these steps again and again till we reach x is equal to y. Let us see what is this circle points. So this circle point is based on the 8-phase symmetry of a circle. So we have calculated only one point x comma y, and we have to assign the other 7 octant values based on this x comma y. So we plot we want to move the value to the center xc comma yc, so we just add it to the calculated point x comma y. So we plot xc plus x comma yc plus y, xc plus x comma yc minus y, xc minus x comma yc plus y, and xc minus x comma yc minus y. So here you can note, see, xc plus x, all these values are x and these values are y, and we have a sign interchange. So if you imagine plus as 0 and minus as 1, then we'll be having all the 4 combinations. So plus 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 minus minus plus minus minus. The same way, the next set of points will be plotted by interchanging x by y and y by x. When you interchange, you'll be getting the next set of points. So all the 8 octant values will be calculated very easily. So though it looks lengthy, it is very simple to identify. If any one of the sign is missing, the circles may not be generated properly. So they we have to note very carefully. This is our midpoint circle algorithm. Now, let us see how it is going to work. We will trace it. Here, we have to initialize first x0, y0. Let us consider the center as 0, 0 and radius is equal to 10. So, the initial value of x0, y0 is equal to 0, 10. And P0 is equal to 5 by 4 minus R. Let me imagine 5 by 4 is 1. So, it is 1 minus 10, that is equal to 9. Now, at each position xk, starting at k is equal to 0, go from the following test. So, let us trace. We just imagine x is equal to 0, 10. x0, y0 is 0, 10. Pk value is going to be minus 9. Now, pk is, we are just going to this condition. Here, we say that pk is less than 0 means we have to execute this part. If it is greater than 0, we have to go for this part. So, let us see if pk is less than 0. Now, pk is less than 0. Then, pk plus 1 is equal to pk plus 2xk plus 1 plus 1. So, we will calculate this 2xk plus 1, that is equal to 2xk plus 2. So, we will just say 2 into 0, 0 plus 2 is 2. Since pk is less than 0, we don't want our yk plus 1, we will come here. Pk is less than 0, we increment only x value. Increment only x. So, increment x and keep the same y value. calculate pk. So pk is equal to previous pk plus 2xk plus 1 plus 1. 2xk plus 1 is here already. So it is minus 9 plus 2 plus 1. So that will become minus 6. Once again it is negative. So we need only xk plus 1 value. We'll just calculate 2 into 1, 2 plus 2 is 4. Now pk is less than 1. So we increment the x value and keep the y value as it is. And the pk value is negative. So we just go for calculating the pk. pk plus 1 is equal to pk minus 6 plus 4, that is become minus 2 plus 1, that will become minus 1. So once again minus, so we'll calculate 2xk plus 2. It is 2 into 2, 4. 4 plus 2, 6. Now we keep the pk is negative, so we increment x by 1 and we keep the same y value. We'll be getting pk is equal to pk is minus 1 plus 2xk will become 6 minus 1 plus 6 plus 1, that will become 6. Now pk is positive. It is greater than 0. So we may require both the values. So we come to this part, else part. So here pk plus 1 is equal to pk plus 2xk plus 1 plus 1 minus 2yk plus 1. So we'll calculate both the values. It is 2 into 3, 6, 6 plus 2, 8. And 2yk plus 1 is equal to 2yk minus 2, that is 2 into 10, 20, 20 minus 2, 18. So we'll calculate the pk plus 1. So pk plus 1 is equal to pk plus 1 pk plus 2xk plus 1, that is 6 plus 8, 6 plus 8 minus 1 minus 18, that will become minus 3, and we increment x by 1 and also decrement y by 1. So here once again pk is negative. We calculate the xk, we will just increment the x value by 1 and we keep the same y value and we calculate the new pk. pk is equal to pk plus 2xk plus 1 plus 1. 2xk plus 1 is 2 into 4 is 8, 8 plus 2, 10. So that is equal to minus 3 plus 10 plus 1, that is 8. Like this, we calculate all the points and we stop when x is equal to y, that is x and y is equal to 7. Let us plot all these things on our circle. Starting from 0, 10, we plot the points like this. So it is once it reach 7, 7, we stop. This is the top right quadrant, and by using the 8 symmetry principle, we just plot the remaining points. I have shown only one octant. The remaining octants can also be plotted. This is our midpoint circle algorithm. You can read for more details Computer Graphics by Donald Hearn and Pauline Becker. Have a nice day.